Hi friends, welcome to App Coders. This is Vikas. Firstly, Happy New Year to all of you, as this is the first video of 2023 and third video in continuation to the generic series. So, in the previous two videos, we learned about what actually generics are, how generics are useful to us, and how can we create custom types with the help of generics, and how can we use protocols to achieve generics using associated types. And how can we apply constraints on generics. If we want to learn any of these, so please go through previous two videos of this series. Now this video is going to be on the bit advanced level. So in this video, we are going to learn about opaque types, existential types, how they are different from generics, and how they are different from each other. So in the next video, we are going to cover some interview questions, and I'm pretty sure you will definitely able to answer all of these after watching this series. So let's start. Here is the quick recap about generics. As we know, generic code enables you to write flexible, reusable functions and types that can work with any type, subject to the requirement you define. Here are the examples of the generics. In this function call, T and U are generic types. And in this custom type example, where element is the generic type. Next, we have associated types. Like we know, when declaring the protocols, we can define associated types. Associated types are the placeholder to the type that is used as a part of the protocol, and the implementer is deciding the actual type. So the actual type to use for that associated type is not specified until the protocol is adopted. And associated types are defined with the associated type keyword. Like here we declared the protocol container, and we define the associated type as an item. Next we have opaque types. Opaque types, somewhere solving the problem arises due to associated types. Opaque types are the placeholder for the specific concrete types, and the specific concrete types that is substituted in is are called the underlying types. We define the opaque types with the sum keyword. If you don't get much here, so don't worry about it. We are going to learn more about it with some practical examples. So firstly, what actually opaque is? Opaque means from which you cannot see through, and the transparent which you can see through. So now let's learn a bit from the practical example. So let's start. Here we have animal feed protocol, and flash and grass is of animal feed types. And here we have one another protocol named animal, where feed type is the associated type for the animals, and function eat and a property called name which is of type getter and setter. And here we have lion is of type animal, which has a feed type of flash and the name property as lion. And here we have horse is of type animal, uh, and horse has a feed type of grass and name horse. And chicken is of type animal, has a feed type of grass and name chicken. So now let's create one function which accepts the animal type. So let's create one function feed animal. Let's say accept animal. So here we created one function feed animal which has a generic parameter t, and t should conform to animal protocol. So now let's call this function name. Example, we passed here horse, so this should work fine. Yes, so here we get the name of the animal as a horse. So now let's replace it with some animal. So this should also work fine. Here sum is nothing but an opaque type. So we created a function which accepts the opaque types. We can also create function that return some opaque types. So let's create function. I'm keeping the same name as this function has no parameters. Let's say return chicken, and let's call this function as well with a print statement. So this should work fine. Yes. So here is a bit difference. In the function which accepts the opaque type, caller knows the underlying type named horse, and the function that returns the opaque types itself knows the underlying type. How opaque types are helpful to us? Let's assume we are working on an application that has different modules, and we are calling this function from some different module. So we can feed different type of animals outside of the module that doesn't aware about how we are feeding the animals. And in this function, we can use this function in a variety of ways without changing the return type. As instead of providing the concrete type as a function return type, the return value is described in terms of the protocol it supports. So hiding the type information is useful at boundaries between the modules and the code that calls into the module. And the underlying type remains private throughout the module. We can also use opaque type with generics at a same function. Like we can use this function in a other way like this. Here we are providing animal feed. So let's make it capital T. And we can simply call this here as it is returning chicken. So here we can utilize the feed, and after, like, if we need to do apply some logic on the feed and then need to return the animal type, we can use in this way as well. This will also work fine, as we are accepting feed through generics and returning an opaque type. So next, now if we get a requirement to create a function that can feed all different type of animals, so let's create a function that can accept array of different type of animals, right? So let's create one function, feed all, and firstly we are checking whether some animals helps us. So let's write some animal, and for calling this function we need an array of some animal, right? So let's create an array. As we are checking whether some animal work for us, so I have created an array, And here we have chicken, lion, horse, and here we should get an error. Yes, type of expression is ambiguous with more context. Here there is a point to note: with the sum there is a specific underlying type that cannot vary. Because the underlying type is fixed, all of the elements in the array need to have the same type. To check this, let's copy paste this array, and if we keep all the items of the chicken type, now this should work fine. So some animal is keeping all the items of the chicken type. Note of the different type of animals. Now, how can we do? How can we store different type of animals in the array? Then we can store it with the any keyword. So this is something new introduced here in this call. So what this any keyword is, and how is this any keyword different from this any keyword? We have one more any keyword in the Swift. How is this different from this any keyword? So we will discuss the difference between these two any in a bit while. So let's park this question for now. So we can express any arbitrary type of animals by writing any animal. The any keyword indicate this type can store any arbitrary type of animals, and the underlying type of the animals can vary at runtime. Any animal is a single static type that has a capability to store any concrete type dynamically, which allows us to use subtype polymorphism with value types. So to allow for this flexible storage, the any animal has a special representation in memory. We can think of this representation like a box. So the concrete type are stored inside the box. When we need the concrete type, we need to open the box and take out the concrete element from the box. The static type, any animal that can dynamically store any concrete animal type, is formally called as existential types. And the strategy of using the same representation for different concrete types is called type erasure. The concrete type is set to be erased at the compile time, and the concrete type is only known at the runtime. So we can use type erasure to write a heterogeneous array of value types, which is exactly what we want for the feed all function, right? So now let's call this feed all function. We can call this, right? And here, yes, so any animal cannot conform to animal. We can remove this error by applying any here as well. So now this should work fine, and within the function we can traverse all the animal one by one. For animal in animals, and we can call this function from here, some animal that can accept animal. Now this should work fine. So we can call the feed animal function that accept some animal from the any animal. Like from the any animal, we are extracting animal and passing it to the some animal. Now here at the sum, we have the concrete type of the animal. Now we can apply any operation whatever we want on the enemy. So we have seen with the sum keyword, we can store underlying types of the similar type. And with the any keyword, means with the existential types, we can store arbitrary concrete types. So wherever possible, you should use a sum, because any will cost you performance a bit, because it is figuring out the concrete types at the runtime. Concrete type is not known at the compile time for the existential types. Next, what is the difference between this any with a capital A and any with a small a? They both are looking similar, but their purpose is completely different. So this any was introduced in Swift 3 to increase the interoperability between Swift and Objective-C, as the Objective-C was supporting only reference types and Swift supports value type as well as reference types. So whatever the ID was doing in the Objective-C, so any is doing in the Swift. So any is used to support all type of instances, whether it's a value type or it's a reference type. And for this any, we have seen how we are using it with the existential types. So thank you guys. That's it for the today video. Hope you like the video. Please do like and subscribe the channel, as new video comes out every week. So see you in the next video.